Beneath Earth's ancient crust, secrets older than the dinosaurs whisper of a forgotten truth. Microscopic traces of titanium, uranium, and plutonium, etched in patterns echoing modern nuclear fallout, lie embedded in rocks predating humanity by millions of years. We believe we were the first to harness fire, forge steel, and reshape the world. But what if we were wrong? What if civilizations, wielding technologies beyond our wildest dreams, rose and fell in Earth's deep past, their legacies buried by time's relentless tide? The Silurian Hypothesis beckons us to unravel this enigma, guiding us through cryptic isotopes, vanished cities, and cosmic relics that pulse with the saga of lost empires. Embark on a journey that will ignite your imagination and redefine your place in the universe. The shadows of ancient minds call. Will you answer? In 1980, geologist Walter Alvarez stood in Italy's Gubbio Valley, staring at a thin clay layer that upended history. Laden with iridium, rare on Earth, abundant in asteroids, this band, marking the Cretaceous-Paleogene boundary 66 million years ago, held levels 30 times higher than normal, proving an asteroid's role in the dinosaurs' demise. This discovery ignited a question. If a single cataclysmic day could leave such a mark, what traces might an advanced civilization leave? Would we, blinded by our assumed primacy, even recognize them? The Silurian Hypothesis, inspired by a fictional Doctor Who species, posits that industrial civilizations thrived millions of years ago, their evidence obscured by geological time. Human civilization, a mere 10,000 years, spans just 0.00002% of Earth's 4.5 billion year history, a fleeting whisper in a cosmic epic. Industrial societies scar the planet. Carbon dioxide spikes, microplastics, and radioactive isotopes persist for millennia. Could ancient societies have left similar signatures, their technologies mistaken for natural phenomena? The quest to find them challenges everything we know. Earth's fossil record is a broken saga, with gaps that hint at untold stories. The Cambrian explosion, 541 million years ago, saw complex life, trilobites with compound eyes, mollusks with intricate shells, emerge abruptly without clear precursors. Before, only microbes thrived. Afterward, oceans teemed with diversity. Paleontologists cite preservation biases, but anomalies persist. The Ediacaran biota, 570 million years ago, introduced fractal-like organisms, vanishing with carbon isotope spikes suggestive of ecological manipulation. Dated to 570 million years ago in Australian shales. The Permian Triassic, Great Dying, 252 million years ago, eradicated 96% of marine and 70% of terrestrial species. South China's Meishan section reveals carbon-13 depletions, mirroring fossil fuel combustion, alongside organophosphates targeting biochemical pathways, hinting at technological catastrophe. The Ordovician Silurian extinction, 445 million years ago, shows cobalt and nickel isotopes in Norway's Oslo Basin, suggesting orbital weapons. These gaps, aligned with chemical anomalies, raise a haunting question. Did ancient civilizations reshape life's trajectory? The rock record hums with anomalies. Pacific sediments from 100 million years ago in the Ontong Java Plateau contain synthetic polymers, degradation resistant, like plastics, absent from natural processes. Colorado's Morrison Formation, 150 million years old, holds titanium microspheres, matching industrial byproducts. Australian Pilbara shales, 300 million years old, reveal vanadium enrichments indicative of heavy industry. Baltic sea cores, 200 million years old, show osmium anomalies pointing to chemical manufacturing. Antarctic ice cores, spanning 800,000 years, capture synthetic fluorocarbons, dated to 500,000 years ago, suggesting climate engineering. Greenland's ice, 3 million years deep, holds xenon isotopes from fusion reactions, dated to 50 million years ago. Kazakhstan's Karatau Basin, 50 million years old, contains uranium patterns akin to nuclear tests. Pacific Clarion-Clipperton Zone sediments yield plutonium, a hallmark of advanced reactors, tied to 66 million year old extinctions. These global signatures, spanning eons, point to industrial civilizations far beyond our own. The evidence stretches beyond Earth, weaving a tapestry of ambition. Lunar radar surveys, conducted in 2025, reveal far-side structures, 200 million years old, built from radiation-resistant alloys matching Earth's geological signatures. These complexes, in the Aitken Basin, include electromagnetic mass drivers for launching payloads to Mars. Martian orbital scans, 2025, uncover Valles Marineris grids, 150 million years old, with oxygen isotope spikes indicating terraforming that sustained Earth-like conditions for millennia before collapse. Asteroid belt scans, 300 million years old, show disassembled asteroids with synthetic polymer linings linked by maglev networks for interplanetary transport. Europa's icy crust, 200 million years old, bears mining scars extracting water and organics. Kuiper belt signals detected in 2025 encode Earth's environmental data, 400 million years old, suggesting a galactic monitoring network. These relics paint civilizations that mastered Earth and reached for the stars. Ancient civilizations left messages crafted for future minds. Siberian permafrost crystals, 300 million years old, encode star charts and fusion schematics in molecular lattices, stable for eons. Pacific ocean cores, 200 million years old, hold nanoparticles arranged in mathematical patterns detectable only by advanced materials science. Arctic ice cores, 500,000 years old, contain synthetic molecules, detailing carbon capture, offering solutions to modern crises. Himalayan quartz, 250 million years old, uses isotope ratios to encode nuclear physics principles, requiring global coordination to decode. Brazilian amber, 100 million years old, traps insects with artificial chromosomes storing orbital maps. These time capsules, designed for civilizations facing technological hurdles, provide blueprints, antimatter propulsion, ecological stabilization, and warnings of past failures, resource depletion, nuclear conflicts. They suggest a cosmic dialogue, guiding successors towards sustainability. The Silurian Hypothesis reveals a cycle. Civilizations soar to godlike heights, only to crash under their own ambition. Their signatures, nuclear isotopes, synthetic polymers, atmospheric spikes, mark collapses from ecological ruin or war. Our path mirrors theirs. Climate tipping points loom by 2050. AI risks escalate. Resource wars threaten. Yet, our global communication networks, open science, and ecological awareness offer a chance to break this cycle. Crystalline archives provide fusion energy designs. Genetic legacies offer climate-resilient organisms. Orbital relics hint at interstellar alliances. Seismic patterns in the Ring of Fire detected in 2025, suggest active guardian systems mitigating disasters. Human DNA, enhanced 100,000 years ago, shows cognitive boosts too precise for natural evolution, implying ancient seeding. Will we join the galactic tapestry or fade into Earth's strata? Imagine walking a planet sculpted by minds like ours, their cities dust, their dreams encoded in stone. The Silurian Hypothesis unveils a saga spanning billions of years, each civilization a verse in Earth's epic. Their triumphs, planetary engineering, spacefaring fleets, eternal archives, are beacons. Their failures, nuclear ruin, ecological collapse, warnings. We are not the first, but we could be the last to fail, armed with their wisdom etched in crystals and orbits. The universe watches as we teeter on the edge. Will we harness ancient knowledge to endure, or become another whisper in deep time? The clock ticks. 2050 looms. Deep time waits for no one, and the legacy of lost worlds demands we act now. Our carbon footprint scars Earth's climate, but we are not alone. Antarctic ice cores, 800,000 years deep, reveal greenhouse gas spikes. Carbon dioxide, methane, dated to 500,000 and 120,000 years ago. Too systematic for natural cycles, suggesting global energy use. Indian Ocean sediments, 150 million years old, contain synthetic sulfates, implying climate engineering with precision beyond our grasp. Greenland's ice, 3 million years old, holds hexafluoride gases, stabilizing Earth against ice ages. North American soils, 200 million years old, show precipitation shifts tied to engineered ecosystems, with pollen distributions defying natural patterns. These interventions, sustaining massive populations, indicate civilizations that sculpted Earth's atmosphere, their failures marked by rapid reversions in Pacific cores, 200 million years old, hinting at abandoned experiments. Earth's atmosphere, a 4.5 billion year chronicle, preserves technological fingerprints. Myanmar amber, 100 million years old, traps air with 35% higher oxygen, artificially enriched for vast populations or alien biochemistries. Polar ice cores, 250 million years old, show nitrogen isotope shifts, enhancing industrial combustion. Pacific Ontong Java sediments, 200 million years old, hold perfluorocarbons for heat retention and UV shielding unique to our solar system. Siberian quartz, 220 million years old, encases gases toxic to modern life. Optimized for alien metabolisms, suggesting Earth hosted multiple engineered biospheres. These atmospheric tweaks, layered across eons, reveal civilizations that rewrote the sky, their failures marked by chemical reversions, warning us of unsustainable ambition. Earth's 5 mass extinctions bear technological scars. The Permian Triassic Great Dying, 252 million years ago, shows organophosphates in South China's Meishan rocks, targeting biochemical pathways with global precision, suggesting biological weapons. The Ordovician Silurian extinction, 445 million years ago, reveals cobalt isotopes in Norway sediments, hinting at orbital strikes. The Cretaceous Paleogene extinction's Chicxulub crater, 66 million years old, contains uranium anomalies, suggesting guided asteroid impacts. South Atlantic cores, 252 million years old, hold engineered microbes disrupting metabolisms, tied to the Great Dying. Each extinction cleared niches for new life, as if orchestrated to reboot Earth's biosphere, raising questions of deliberate planetary resets by ancient minds. Antarctica's ice hides a technological marvel. Trans-Antarctic drilling, 2025, uncovers synthetic hydrocarbons 10 million years old for industrial combustion when the continent was temperate. Radar reveals geometric grids 15 million years old, built from non-terrestrial alloys, spanning hundreds of miles. Ross ice shelf cores yield DNA with artificial sequences, engineered for cold-resistant organisms, dated to 12 million years ago. Amundsen sea sediments contain nanotechnology gears, 10 million years old, suggesting precision engineering. Geothermal power grids, detected via radar, unified Antarctica's energy systems, dwarfing modern output. Rapid cooling signatures, 12 million years old, imply deliberate preservation of this civilization's legacy, frozen for future discovery. Lunar structures, 200 million years old. In the Aitken Basin, house mass drivers launching payloads to Mars using alloys matching Earth signatures. Martian Cydonia grids, 150 million years old, show oxygen spikes from terraforming, sustained for millennia. Asteroid belt scans, 300 million years old, reveal disassembled asteroids with maglev networks. Jupiter's atmospheric platforms, 250 million years old, harvested helium-3, enduring extreme conditions. Callisto's mining scars, 200 million years old, extracted water and organics, supplying system-wide manufacturing. Kuiper belt signals, 400 million years old, encode Earth's geological data, detected in 2025, suggesting a galactic network. These autonomous systems, surviving Earth's collapses, indicate civilizations that wove the solar system into a unified technological domain. South Africa's Witwatersrand quartz, 2.8 billion years old, encodes orbital mechanics in carbon nanotubes, suggesting geological computers. Siberia's Lena pillars, 400 million years old, hold graphene lattices with Devonian climate models. Atlantic Nair's abyssal plain sediments, 300 million years old, contain synthetic silicates, implying global data networks. Pilbara Creighton stromatolites, 3.5 billion years old, bear bioengineered enzymes for metal extraction, with zinc anomalies predating complex life. These subterranean archives spanning billions of years preserve technological wisdom, from planetary monitoring to industrial processes, waiting for discovery by minds advanced enough to decode them. Mongolian Nemec dinosaur bones, 70 million years old, contain synthetic DNA, enhancing radiation resistance. Canadian Arctic trilobites, 500 million years old, show gene edits for shell durability. Brazil's Santana fish fossils, 110 million years old, integrate chloroplasts for photosynthesis. Pacific Emperor seamount microbes, 200 million years old, sequester carbon dioxide, stabilizing climates. Greenland's Isua rocks, 3.8 billion years old, hold cells with artificial organelles, suggesting early terraforming. Carbon-12 enrichments indicate global engineering, crafting life to sustain industrial ecosystems across eons. Each species a testament to ancient bioengineers. Venus's Maxwell Montes, 500 million years old, hosts atmospheric processing stations. Mercury's Caloris Basin, 300 million years old, holds rhodium from solar mining. Ceres's Okator crater, 400 million years old, contains energy storage crystals. Callisto's cavities, 200 million years old, match Earth's nuclear signatures, suggesting refueling depots. Voyager detected gravitational anomalies, 100 million years old, near the heliopause, imply Dyson swarms aligned with Earth's star charts, detected in 2025. These relics, scattered across the solar system, weave Earth into a cosmic network of technological ambition, enduring beyond planetary collapse. Atacama Desert Salt, 200 million years old, encodes holographic star maps. Indian Ocean nanodiamonds, 150 million years old, store antimatter algorithms. Ethiopia's Afar basalt, 300 million years old, holds magnetic sequences resembling music. Antarctic helium, 3 deposits, 50 million years old, detail fusion energy. Siberian permafrost neural matrices, 30 million years old, preserve consciousness, emitting quantum signals awaiting contact. These capsules, designed for future civilizations, offer solutions to energy, climate, and survival challenges. Their messages are a bridge across deep time, urging us to learn from past triumphs and tragedies. Australian cave star charts, 350 million years old, map galactic structures, confirmed by 2025 telescope data. Interstellar signals, referencing Earth's coordinates, 200 million years old, align with Proxima Centauri megastructures. Human DNA, enhanced 100,000 years ago, shows cognitive tweaks for alien environments, suggesting galactic bioengineering. Gobi Desert platforms, 200 million years old, served as interstellar hubs, coordinating cultural exchange. Interstellar traffic patterns, detected in 2025, suggest ongoing activity invisible to us. Galactic councils, referencing consciousness archives, govern cooperation, inviting humanity as we near technological maturity, positioning Earth as a vital node in a cosmic tapestry. Russia's Kola Peninsula basalt, 2 billion years old, holds graphene microtools, suggesting quantum computing. Himalayan shales, 400 million years old, yield polyalloy filaments for energy conduits. Mongolian Altai grids, 300 million years old, hint at buried cities, visible only from orbit. Sahara dunes, 200 million years old, conceal atmospheric processes. These artifacts, crafted with molecular precision, indicate civilizations building on their predecessors' foundations, reshaping continents with technologies centuries beyond ours. Their purposes, computation, communication, still eluding us. Arctic ocean cores, 150 million years old, contain silicate aerosols for solar reflection, stabilizing climates. Indian subcontinent rocks, 250 million years old, show magnesium isotopes from desalination, supporting coastal ecosystems. Lunar mare basalts, 200 million years old, hold propulsion components for interplanetary craft. Vesta's tunnels, 300 million years old, are lined with synthetic ceramics, implying interstellar mining. Namibian fossils, 180 million years old, contain nitrogen-fixing microbes, boosting fertility. Australian reefs, 350 million years old, hold photosynthetic plankton, sustaining industrial oxygen levels. These feats reveal civilizations that sculpted planets and stars, their legacies enduring in Earth's crust and beyond. Mariana Trench sonar maps, 250 million years old, reveal pressure-resistant alloy cities, powered by thermal vents at efficiencies dwarfing modern technology. Pacific cores, 200 million years old, hold bioengineered algae for nutrient recycling, sustaining self-sufficient ecosystems. Philippine trench shafts, 180 million years old, connect to surface levels, implying global networks. Submersible artifacts, quantum processors, antimatter conduits suggest these underwater hubs powered interplanetary missions, their stability enabling million-year projects. Sediments reveal microbes engineered for deep-sea mining, extracting rare earths, positioning abyssal cities as the backbone of ancient empires. Lunar mass drivers, 200 million years old, launch payloads to Mars, matched by Sidonia's terraforming grids, 150 million years old, with oxygen residues. Asteroid belt networks, 300 million years old, transported processed materials. Jupiter's helium-3 platforms, 250 million years old, operated in extreme conditions. Callisto's mines, 200 million years old, supplied system-wide manufacturing. Kuiper belt signals, 400 million years old, relay Earth's data, detected in 2025, indicating a unified solar system economy, autonomous after Earth collapses, treating planets as a single technological domain, resilient to catastrophe. Himalayan quartz, 300 million years old, encodes fusion schematics and ecological warnings. African rift rocks, 250 million years old, detail nuclear physics via isotope ratios. Arctic ice, 500,000 years old, holds carbon capture molecules. Pacific nanoparticles, 200 million years old, encode mathematical principles. These messages, tailored for technological civilizations, offer sustainable solutions and warn of resource depletion and war. Automated systems detected in 2025 seismic data. Update these archives, triggering revelations as humanity nears critical thresholds, fostering a cosmic dialogue that guides us towards sustainability while preserving autonomy. Ancient civilizations rose to stellar heights only to fall within 10,000 to 50,000 years. Permian-Triassic sediments, 252 million years old, show carbon spikes and toxins, signaling ecological ruin. Siberian nuclear isotopes, 200 million years old, align with collapses, suggesting warfare. Orbital stations, 150 million years old, abandoned post-Earth collapse, indicate failed off-world colonies. Their climate stabilizers and fusion reactors, found in Antarctic cores, could have ensured survival, but were misused, leading to catastrophe. Our path, 2050 climate deadlines. AI risks mirrors theirs, but global collaboration and ancient warnings offer a chance to break this cycle. Himalayan seismic networks, 300 million years old, monitor geology, correlating with 2025 earthquake patterns to prevent disasters. Pacific cores, 200 million years old, show atmospheric tweaks countering climate swings. Human innovations, penicillin, quantum computing, emerge suspiciously timed, possibly guided. Human DNA, enhanced 100,000 years ago, suggests seeding for resilience. Deep-sea arrays, 250 million years old, transmit progress reports, possibly to off-world survivors. These adaptive systems preparing for contact as we near technological thresholds. Balance guidance with independence, ensuring our growth. Quantum analysis, 2025, reveals Planck's constant variations, 2.5 billion years old, tied to evolutionary leaps like the Cambrian explosion, driving complex life. Space-time fluctuations encode quantum computers, 3 billion years old, manipulating fundamental forces. Greenland's gravitational anomalies, 1 billion years old, suggest invisible megastructures stabilizing Earth's geology and atmosphere. Biological evolution, like mammalian intelligence 200 million years ago, shows guided genetic tweaks. Atmospheric stability, defying natural chaos, indicates regulators maintaining life-supporting conditions, revealing civilizations that engineered reality itself. Deep space sensors, 2025, detect Lagrange point stations, 400 million years old, deflecting asteroids with precision, dated to 300 million years ago. Solar satellites, 250 million years old. Counterflares, preserving atmospheres. Lunar magnetic generators, 200 million years old, reinforce Earth's magnetosphere. Orbital debris systems, 150 million years old, clear threats using field technologies. Interstellar networks, via cosmic ray modulations, link Earth to galactic defenses, revealing themselves as our sensors advance, signaling our readiness to inherit these protective systems. Quantum archeology, pioneered in 2025, extracts data from space-time fluctuations. Australian quartz, 2 billion years old, reconstructs fusion reactor designs. Earth's quantum vacuum, 3 billion years old, stores every technological event, maintained by archival systems. Solar system entanglement networks, 400 million years old, enable instant communication, recover blueprints, detail energy and material science, offering climate solutions. Pacific time capsules, 200 million years old, guide sustainable development, activating as we reach technological maturity, challenging us to wield this wisdom responsibly. Deep sea artifacts, 250 million years old, reveal neural interfaces for consciousness uploads, preserving minds in Himalayan crystals, 300 million years old. These virtual societies, active for eons, evolve within quantum fields, their protocols awaiting contact as our sensors advance in 2025. Some systems enable transfer to biological or robotic forms, suggesting resurrections. These eternal minds, surviving extinction, redefine death as a transition, urging us to join their timeless community as our neural research aligns with their technologies. Kepler, 452 megastructures, 1 billion years old, match Earth's signatures. Cosmic ray signals, 500 million years old, reference Earth's coordinates. Antarctic star charts, 400 million years old, map distant systems, implying interstellar travel. Gobi platforms, 200 million years old, coordinated galactic exchange. Interstellar traffic, detected in 2025, suggests ongoing activity. Galactic councils in consciousness archives invite humanity as we near maturity, positioning Earth as a cosmic hub in a billion-year network of technological kinship. The Silurian Hypothesis unveils Earth as a crucible of intelligence, its strata a saga of genius and ruin. We teeter on the edge. Climate collapse by 2050. AI risks resource wars, echoing ancient failures. Yet, global networks, open science, and cosmic archives offer hope. Quantum blueprints provide sustainable energy. Genetic legacies ensure resilience. Galactic relics beckon to interstellar kinship. Guardians pulse in space-time, guiding us. Our trial looms. Will we succumb to hubris or forge Earth's first enduring civilization? The galactic chorus awaits. Act now or fade into the eternal void. Consciousness preservation systems, pulsing in Himalayan crystals, 300 million years old, activate in 2025. Poised to guide humanity through this pivotal transition. Their quantum protocols, embedded in Pacific sediments, offer ethical frameworks for immortality. Warning of social fractures seen in Siberian isotopes, 250 million years old. Arctic cores, 200 million years old, provide climate engineering blueprints, carbon sequestration, atmospheric stabilization to avert 2050 tipping points, demanding we shift from consumption to regeneration. African rift warnings, 300 million years old, highlight risks: unchecked AI, resource conflicts, overpopulation. Kepler 452 signals, 1 billion years old, suggest galactic councils grant access only to sustainable civilizations, ensuring cosmic stability. Our neural research, advancing in 2025, nears consciousness preservation, offering survival but requiring ethical rigor to avoid abuses seen in Antarctic archives, 50 million years old. Lunar guardians, 200 million years old, monitor our trajectory, ready to intervene with atmospheric tweaks or asteroid deflections, preserving autonomy. This choice, sustainability over dominance, must be made within decades. Martian terraforming, 150 million years old, shows sustainable paths. Siberian nuclear residues, 200 million years old, warn of failure. We inherit a cosmic legacy. Quantum archives, eternal minds, galactic networks, sacrifices of civilizations that perished to ensure our chance. Consciousness, encoded in space-time, is the universe's self-awareness, a force we must wield to shape existence. The Silurian Hypothesis unveils humanity as a chapter in a billion-year epic, not first nor last, but pivotal. Future archaeologists will judge us. Did we squander this inheritance or forge a legacy enduring beyond Earth? The universe's symphony awaits. Seize the cosmic mantle, or vanish into deep time's silent verdict.